Hello, I'd like to talk to you about ThinkBase, our knowledge graph system, and the machine learning abilities that we've just added into it. So hitherto, ThinkBase could be constructed, ThinkBase knowledge graphs could be constructed by hand, and data could be loaded into them quite happily. But now we've added the ability to create knowledge graphs directly from data as a form of machine learning. Now, machine learning has been built into the underlying DAL system for a very long time, but we've now extended it so that it works with ThinkBase. Currently, we've got supervised learning, unsupervised learning is on the way, and reinforcement learning would be the next thing after that. So if you look here at this GitHub page, ThinkBase-AI machine learning _examples, that's our page that contains multiple machine learning examples that you can load into the system. And we've tried to make them really simple by creating GraphQL scripts that you can just simply dump straight into our software as a service system using our Playground GraphQL interface. So we're going to look at the biggest one of these right now, which is the Cleveland Heart data. If you click on the Markdown, you get a description of the whole thing. Basically, the Cleveland Heart data is looking at people who had heart problems, some 300 of them, and trying to predict what the result would be of a nasty invasive procedure, which works out how much arterial narrowing they've got. Arterial narrowing ranges from 0 to nothing, to 1, 2, 3, and 4 being more and more arterial narrowing. So there are 13 input features, which are all detailed down here, and one predicted value. So what we're going to do is create a knowledge graph out of this that you can actually interact with, that you can then interrogate afterwards, and potentially put a new heart attack patient in and get an estimate of arterial narrowing out of. So let's go back to the main page. So just to show you what the data looks like, this is the data arranged in a nice user-friendly form. You can see that we've got cases as the top level, is the root. Then we've got case items. These each correspond to a training example, a patient in fact, but also a training example. And then we've got all the data items in beneath that. And so we've got the 303 data items there. All right, but this data is provided just simply so you can see how it's arranged. If we look at this page, we can see this is the data that we're going to put into, or the script rather, that we're going to put in our software as a service GraphQL interface. So this is GraphQL script language, which is a kind of cut down JSON, and it contains build, which is the command. So we're going to build a knowledge graph. Name of the knowledge graph to generate, Cleveland Heart.graph. The data, so this is all, basically all that data is crammed in there. You can also use data that you've loaded into the system. So where you've got much larger examples than this, 303 examples, you can load the data as you like, slowly, and then thereafter run a training process on it. So the pattern path is the X path, because we've got XML data to get down to the individual examples, the individual patterns. And then below these, we've got specifications for each of the data items. You can use XML, JSON, or CSV. In the case of CSV, it's assumed that each row is a data example, so you don't need the pattern path for CSV. If you're using JSON, then you've got to use JPath in here, which is very much like XPath, but there you go. So these are for navigating tree-shaped data. If you've got just simple CSV tabular data, then you don't need those. Beyond that, then we specify the individual fields, and because we're using XML, we've got here, this is the predicted value, the value we want to predict, and you can tell it's predicted because we've got target equal true in it, not true of any of the others beneath, you see. The rel path here is the relative path to this point, so that's the X path that you need to find this data value relative to the pattern path. We've also got specified the data type, which is categorical. The value we're predicting is categorical. And then we've got all the other values, some of which are numeric, some of which are categorical. The object lineage is worth talking about. This lineages are a complex subject, and I suggest that you take a long look at the ThinkBase site in order to understand them, but they're a kind of universal way of specifying data. So in this case, these lineages are based on WordNet, or our expanded version of WordNet, and this is the lineage for archery, and this is the lineage for narrowing. So what we're saying is that this is a mechanism for predicting archery narrowing. That's all the data, all the different fields, and then right down the bottom, the thing we're asking from the system is the train performance and the test performance. So when we run this, it will create a knowledge graph and automatically, and then we'll be able to look at it and interrogate that knowledge graph. So what I'm going to do to copy this over is go to the raw version of it, and you can see there really is lots of data in here. Control A to select everything, Control C to copy it, and then I'm going to go to the API interface. So this is the playground interface to the GraphQL internals of the system, and this is the lowest level of communication with ThinkBase, and everything, all the user interfaces we've got, all the tools we've generated, all talk through the same interface. This is the most general way of communicating with ThinkBase. So we can just simply paste in okay, so there it all is, and we can just hit go, and there you go. We've got the results. The train performance 97.8% in sample performance. So our system takes 90% of the data randomly selected to train on, and the remaining 10% is used for test. So we've got 97.8% correct in the training data and 100% correct in the test data. As I say, randomly selected from the source data. Okay, so let's take a look at what that's generated in the knowledge graphs. So there it is there, Cleveland Heart, and this is the knowledge graph it's generated. So there are the 13 data values that feed in, and here is the predicted value. And if we click here, we can see the rules that have been generated. So it's specified various inputs and outputs, and then here it's actually given you rules based on those inputs and outputs. So we can use this in anger by going to the conversation tab, and we can actually then start a conversation as a way of interacting with this knowledge graph. Now there are two ways you can interact with the knowledge graph in our system. You can just simply use the API, the GraphQL API, and just send data, just query that knowledge graph and get a result immediately. Or you can interactively query it, in which case the system will look at the rules and work out what's the most important things to ask for first, and it'll ask those in order until it can determine what the output should be, and then it'll tell you. So we're just going to run through that process. I shall speed it up because it's a bit of typing, of course. You can see that the initial question has been set here. What is the artery narrowing? And it's derived that question from the lineages that we set up in the first place, so it's well worth setting those up. So we'll blast through answering the questions. Now it's got all the data, and it's inferred that the value of outcome is 0, which means no arterial narrowing. So over on the left here, we've got a depiction of the knowledge state that's been built in this process. And that contains the various data items that have been captured. You can see the fact that the value of age is 63, the fact that it's completed, and so on through all the others. And then finally we've got outcome down here. And we've got the predicted value and also the data item that says that's predicted. So this knowledge state is available over the API, and you can actually interact with the system by providing a knowledge state with all or some of the data provided, and then the system just fills in the missing bits and sends the knowledge state back to you. So that's how you can interrogate the system using the API. And the other alternatives, you can use this interactive approach with Microsoft Bot Framework. There's code, open source code for you to do that, with Alexa even, and through the Microsoft Bot Framework you can use a variety of other things. And the other alternative, if you want to have this system in your own servers, is we provide the whole thing as a Docker container. So what you can see here is a multi-user system. The Docker container is a single user system just for you, which simplifies the interface somewhat. But that gives you the ability to do exactly the same stuff as we've done here on your own site. Obviously the Docker container isn't free, but it is a sort of the ultimate solution if you really need to have your own local processing and do all this stuff locally. Well, thank you very much for watching. Bye.